So we're going to move from graphing the rational expressions to solving rational and polynomial inequalities. Now, we've solved quadratic inequalities at this point, but not these two. You'll notice that I have this inequality here. Where is the function of x over x squared minus 1 less than 0? Well, I put a little graph of it over here. We can see it's less than 0 in this region here and in this region over here. So I could, just by looking at the graph, state the answer of negative infinity to negative 1 in union with 0 to 1. Alright, but I'm not always going to have the graph to refer to, so we need to figure out how to do it with this equation here. Well, we have to find these critical numbers. We found those in quadratics, or where the graph either crosses an axis or where it crosses an asymptote in this case and moves from maybe a negative value to a positive value. So to find those critical numbers, you find x-intercepts and asymptotes if there are any. And those would be vertical asymptotes. So my x-intercept in this case is x equals 0. And to find my asymptotes, I set x plus 1, x minus 1, which is the factor denominator, equal to 0, and get plus and minus 1. Then what we're going to do is very similar to what we did with our quadratics. We're going to take those critical numbers, put them on a number line. So negative 1, 0, 1, and check the regions within those numbers and outside those numbers to see what kind of values are output by the function. And the function that I'm going to compare to is this x over x plus 1, x minus 1 form, because it's just easier to pop in numbers here. So I'm going to pick, let's say, f of negative 2, and we know what the answers are going to be, but we're just doing it for kicks to show you what happens. So I'm going to plug these values in to my function here on the right and see what kind of values I get out. If I plug in a negative 2, then I get a negative, negative, and a negative, which is a negative. And that's less than 0, which is what I wanted. If I plug in negative half to this function on the right, I get a negative, positive, and a negative, which is a positive, which is greater than 0. And that's not what I wanted. If I plug in a positive half, I get a positive, and a negative, which is a negative, which is less than 0, and that's what I wanted. And then I plug in a 2, and I get a positive, 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 which is a positive, that's greater than 0, and that's not what I wanted. So these are the two regions where I get my value of the function less than 0, which is what I wanted. I state my intervals here from negative infinity to negative 1 in union with 0 to 1, right? And that's my answer. Again, easy when I've got my function. So here we have a polynomial inequality, and we're asking when are the values of this polynomial less than 0 once again. And you'll notice in this case, we're only going to have intercepts because polynomials aren't going to have asymptotes. They're always going to be defined. So in this case, again, we can look at the graph and say, well, I know where it's less than 0. It's going to be less than 0 in this region here, in this region here. And where do those happen? Well, looks like they happen between, negative 2 and 0. And since it's equal to, I can bracket those guys in union with. This looks, what is that? I don't know, about 2 point something. Let's just go 2.2 for kicks. From 2.2 to infinity. The infinity doesn't get labeled. And now we'll take and do this algebraically. by taking and finding our intercepts. So we're going to set this all equal to 0, solve, I'll pull out a negative x, and get an x squared minus 5, set x equal to 0, or negative x equal to 0, get x equals 0, x squared minus 5 equals 0, so x squared equals 5, and x equals plus or minus root 5. Again, use those critical numbers, 0, plus and minus root 5. I'm going to pick values to either side of those, so let's go 3 here, 1, -1, -3. Pop in a 3, I get a negative and a positive, which is a negative, and that's less than 0, so I like that. Plug in a 1, I get a negative and a negative, which is a positive, which is greater than 0. That's not real good for me. I plug a -1 in, and I get a positive and a negative, which is a negative, which again is less than 0, and I like that. Plug in a -3, I get a positive and a positive, which is a positive, which is greater than 0. I'm not interested in that. So again, as we saw in our picture over on the right, I get an interval from -5 or root 5, which is -2 point something, to 0, and I can include both of those, and that's in union with the root 5 to infinity, and infinity can't be contained, so that's parentheses. Alright, with graphs it's easy. Without graphs, we kind of go through the same rigmarole, but we've got to use a little algebra to solve it. So in this case, I'm going to have to factor to find my intercepts. This is going to factor by grouping, so you'll notice that these two have an x squared in common. I pull that out, leaving me with an x plus 2. These have a -4 in common, left with x plus 2. Now you'll notice, once again, that I have a GCF of x plus 2. I factor out an x plus 2, and I'm left with x squared minus 4, which again factors to x plus 2, x plus 2, x minus 2. So then we're going to look at the critical numbers in this case of -2 and 2, because I've got a multiplicity of 2 right here. So you'll notice I'm going to plug in -3, 0, and 3, and I'm going to plug it into this factored form right here, and I'm looking for values that are less than or equal to 0. So if I go ahead and pop those in, I get a positive, 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 which is positive. That's greater than 0, not what I want. Plug in a 0, I get a positive, positive, and a negative, which is a negative. That's less than 0, and that's what I want. Plug in a -3, that's a negative, 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 which is a negative. That's also less than 0. So you'll notice that in this case, I can be equal to 0 or less than 0. In both of these cases, that's true. So my solution is going to be from -infinity to +2. I get values that work, and then after which I don't get values that work. Now, let's just look at a graph to check what's going on. So here's my graph, and you'll notice, just like our calculation showed, from -infinity all the way up to 2, my graph is underneath the axis, and then from 2 to infinity, it's above the axis. So we've done the math correctly, but you can see getting the information out the graph's a lot easier. We just don't want to have to graph this every single time. And now we have a rational expression. We're going to find intercepts first. So we set x squared plus 2x equal to 0. We get x plus 2 equals 0. I have 0 and negative 2. And then I'm going to factor my denominator. I have x squared minus 9 equals 0. We get x plus 3, x minus 3, and plus and minus 3 here. Now, these are restrictions. All right, or asymptotes. So critical numbers this time, I've actually got 4. I have negative 3, negative 2, 0, and 3, which means I'm going to need to test a whole bunch of points. So let's go with negative 4, negative 2.5, negative 1, 1, and 4. I'm going to have to plug all those into a factored form of the equation, so I'm going to go to x plus 2 over x plus 3, x minus 3. In doing so, I plug a negative 4 in, I get a negative, 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 negative. 4 negatives make a positive. That's greater than 0 and not what I want. 2.5 goes in, negative type, I get 2 negatives on top. On the bottom I get a positive and a negative, which goes to a negative, which is less than 0. And I'm happy about that, so that's going to be part of my solution. If I take and put in a negative 1, that's a negative and a positive on top. On the bottom I have a positive and a negative, which is a positive. That's not what I want. Plug in a positive. 2 positives on top. Positive and negative on bottom, which is a negative, which is less than 0. Happy with that. Plug in the 4 and I'm all positive. So again, this is strictly less than. Nothing can be included in here. So I'm going from negative 3 to negative 2 in union with 0 to 3. And again, we'll check this on a graph. Here's the graph of our function. And you'll notice from negative 3 to negative 2, it appears to be below. Something's going on right here. I can't really tell. Let's just zoom in on it for fun. If I make my little box, go here, my guess is this is going to go above the axis and then back down below. But let's just confirm. So we can see everywhere else it's above the axis. Graph again. And sure enough, it goes above and then dips back below. So our calculated value is right. We didn't have to go through all the painstaking process of graphing it to get that done. So here's our solution. Our last one. Now, this you can be fooled by. In general, what you really don't want to do is you really don't want to multiply by a common denominator to both, because what it does is it takes this rational expression and turns it into some kind of a polynomial where there will be no restrictions. However, we know since they're both rational that there are going to be asymptotes. So what I'm going to do is I'm going to actually just bring the 1 over x plus 3 to the other side. And we want to know when all this is greater than or equal to 0. So now I have to do a little addition. X plus 3 minus x over x times x plus 3. I just got a common denominator, which gives me 3 over x times x plus 3. So now I have no x-intercepts. And in this case, I will have vertical asymptotes at 0 and -3. So these are my critical numbers, 0 and -3. And I'll pick points to either sides of those. And we'll go ahead and test those in this bottom equation over here. So I have a positive on top, 2 negatives on bottom, which is a positive, which is greater than 0. I like that because I'm looking for values greater than or equal to 0. Then I plug in a -1, get a positive on top. On the bottom I get a negative and a positive, which ends up being a negative, which is less than 0, and I don't want that. Plug in a +1, I get a positive, positive, which is greater than 0 because that's positive, and that's what I want. So now I can state my solution once again and say I've got from -infinity to -3, and I can't use either one of these because -3 was a restriction on the domain, and that's in union with 0 to infinity. And I can't use 0 either because 0 was a restriction on the domain. And that's my solution. And let's confirm that with a graph one more time. And you'll see in the graph that up until 3, where I have my asymptote, appears to be above the axis. And then from 0 over, it's above the axis again. So once again, without graphing, we've found our functions or our inequalities answer. That's all we've got. Do the summary, fill out the My Math Lab. We'll see you tomorrow.